All right, so I'm glad that y'all had some time to spend with your Schrady cheat sheet. You need to become fairly intimate and friendly with your Schrady cheat sheet. You need to be good pals. Um, but you will have a Schrady sheet. I have a class set for your quiz and your test. Okay, you can't use your own. Um, really. Yes, because people will just put answers on there and they'll do all kinds of stuff. They'll get the answers from the earlier class period and put it on their sheet. I mean, not y'all, right? Okay. So S is for simplifying, so we have to factor first. How did you factor the numerator? You did not, right? You did not factor it? Very good. And how did you factor the denominator? X minus 3 squared, right? So you can either write that x minus 3, or you can write it x minus 3 squared, whichever you like is fine. Do any factors cancel here? No, so the H step is not applicable. So we go to R. For R means roots. Am I setting the top or the bottom equal to 0? The top. And this threw y'all a little bit because I got lots of answers here. I got lots of -3s for the solution because you're not quite thinking through. Here's how you solve this. You divide both sides by -3. What is 0 divided by anything? 0. So x equals 0, and then on your Schrady cheat sheet, what form do you write that as? A point, 0, 0. Am I going to be circling it for partial credit if you stop right here like this? Yes. This is full credit on this step. This form, okay, the point. And then for A, asymptote, we're setting the bottom factors equal to 0. They're both the same, so you don't have to do that work twice if you don't want to. But it doesn't hurt if you do, like just for consistency. So x minus 3 equals 0. We solve x equals 3. Do I need you to write this as a point for full credit? No, because this is already how it needs to be. It's a line. Let's see. So I need that as a point, that as a line. And I'm going to go ahead and put those on my graph. Here's my root and then my x-intercept, or my asymptote. And then T is tangent over together. Okay, root behavior over asymptote behavior. So tangent means I'm looking in the numerator or any factors squared. There's the x squared. No, so this is no. So it's going to cross when it gets to that root. And then the bottom is asymptote behavior. Is it going to come together or not? Yes, right? It's going to come together because that factor is squared. And coming together means it's, either going down on both sides or it's going up on both sides of the asymptote. That's what together means. And if it's not together, what is it? It's opposite. All right. So that's T. And then E stands for M behavior. And y'all were on that while you were going through your cheat sheet. You're looking at your leading terms. It's -3x on top and x squared on bottom. What is that, balanced or bottom heavy? Bottom heavy. What's the horizontal asymptote by default? Y equals 0, right? That's on your cheat sheet, so that's y equals 0. I'm going to put that in here. And then here's what happened with a lot of you guys. As you're drawing that horizontal asymptote, you notice it goes through that root, and you might think, oh, I thought the graph isn't supposed to cross an asymptote. But this asymptote is for what specific kind of behavior? That starts with an E. End behavior. Remember that the definition of end behavior is the behavior of the graph as x goes to -infinity and as x goes to positive infinity. It means as x gets really, really small or x gets really, really big. It does not determine the behavior of the graph here in the middle. That's why it's okay for there to be a root right in the middle of that horizontal asymptote. Right? That's okay. And then y is for y-intercept. That means you let x equal 0. Technically, I don't have to do any math. I already know it's going to be what? 0, right? The 0, 0. But just for consistency, in case you want to do it like the same way every time so you don't confuse yourself, what you would do is you take that x equals 0, you plug it into the original or the factored form, and then you just simplify. So I'd get -3 times 0 over 0 squared minus 6 times 0 plus 9, and that will give you 0. And I do want this as a point, 0, 0. So we've gone through all the letters, we've gathered all our information, and now we have to Sherlock Holmes the problem. The thing is that when you're looking here, you're like, I don't know how to get started. Okay, several of you said, I don't know how to get started, because there's kind of not enough information. But anytime you need more information, what can you do at any time? A test point, right? You find a test point. I recommend just starting at the left-hand side somewhere, because, I mean, you could do a test point over here, but that's not really going to be helpful. But here you already have a point. So if you had a second point, that would be great. And so you just need something in this, to this side of your vertical asymptote. I'm going to choose x equal 1 because it's not negative, and 1 is really easy to multiply by itself. And so my test point, I'm going to do, I'm going to let x equal 1. And I can plug it into either the original function or the factored function. Which one do you want? Original or factored? Original, okay. So that's negative 3 times 1 over 1 squared minus 6 times 1 plus 9. Be sure you're following your order of operations, because while test points are wonderful, if your math is wrong, it's going to frustrate you more than help you, because it's not going to make sense where your point ends up being. So following my order of operations, I have to do the exponent first, which is 1. Then I do all the multiplications. So it's negative 3 on top, 1 minus 6 plus 9 in the denominator, then negative 3 over 1 minus 6 is negative 5, plus 9 is 4. Okay. So when x is 1, y is negative 3 fourths. And I can plot that, and then it'll help me get started. So 1, negative 3 fourths. So I can see immediately at least this, that as x goes to the right from the root, it's going to look, the graph is going to look like this. I at least know that for sure. Now what it's going to be doing to the left of the root seems kind of weird, okay, because I know that it doesn't bounce there. It'd be easy if it bounced. If it bounced, I would just turn around and come back. But we know from the t step that it's got to cross through. And so that's fine. It's going to cross through. But then what is it going to do? Well, here's where we depend on our end behavior information. I have this horizontal asymptote. I know that as x gets really, really small this way, that however it goes here, it's eventually got to start coming back and approaching this asymptote right here. Okay. So what I'm going to do, because remember, we're just sketching, is I'm just going to like fake it. It's got to go up and then come back down eventually. Now, if that's too loosey-goosey for you and you want to be a little more specific, what could you do in this area? Another test point, okay? Another test point. But I'm okay with something like this general shape. Right? So that's the left side of the asymptote. We still need to sketch in something on the right-hand side. So here's where we use our t information again. What's happening on either side of the asymptote? Coming together. What does that mean? It's going the same or opposite directions? The same. So I know as soon as it gets on this side, as it crosses, it's got to be going down. I know it's never going to cross the x-axis again because I don't have any roots there. I already found all the roots. There was only one. It's never going to cross there again. And as x gets bigger to positive infinity, it's going to approach that asymptote. Bless you. So it's going to go. So I just connect those two arrows. All right. And the reason why we're not doing these bottom two problems is if you were to set the denominator equal to 0 and solve, you'd get imaginary numbers, and that does funky things that we're not gonna talk about. So for your skill check, you need your notes and homework out from Tuesday's lesson. There's no Schrady on your skill check. And for those of you who are new to class, skill checks are pop, daily grades. You can use your notes and homework on. I don't grade them very hard. But you can't help each other. Because I want to see what you are understanding or not understanding. As you finish, turn it into my desk. Today's note sheet is on my desk, so please pick it up when you're back there and resist the urge to get your phones back out. Just don't do it. We do have a lesson immediately after the skill check, but it's short, so that's good. One more? Writing equations from the graph. So the last 2 days we were given the function, and we used Trady to mine some information to create a graph. So now we have a graph, and we're going to write the equation from it. And so I'm going to do, and we just have this one problem. So I'm going to do that thing where I draw the line, and I put the explanations on the left and the problem on the right. Please write the explanations down. You don't have to write exactly what I write. You can use your own personal shorthand. But I find that when you don't write the explanations on the left, because you think there's no way you could forget what we were doing, you're just going to write the work, then you forget why we did what we did. So write some kind of shorthand for an explanation on the left-hand side. All right, here's the first thing I want you to write. The first step that we're going to do is we are going to find factored form of the roots and the vertical asymptotes. Okay, so we're going to find factored form for the roots and asymptotes. I'm doing this to the right of the graph just because I'm on the smart board, so I don't have to scroll. When I did it personally, I did under the graph, so I didn't run out of room. For those of you who that's important to, because it's important to me. And the factored form of the roots and the vertical asymptotes. And so here's what I mean when I'm saying to find the factored form. When we did Schrady the last 2 days, we factored. We set those factors equal to 0, and we solved to get the roots and the asymptotes. So now we're starting with the roots and the asymptotes, going backwards to factored form. And we did this same kind of work last semester, and here's what I mean by that. So how many roots do you see there? Two. There's 2 roots. I've got this one and this one. So this root on the left is negative 1, 0. Well, what factor would give me negative 1 for a root? X plus 1, right? X plus 1. Because I would set x plus 1 equal to 0 and solve, and that's how I would get the negative 1. So the factored form is x plus 1. So the other root is 4, 0. What factor gives me that? X minus 4. Okay, so these are my roots, and I'm switching over to factored form. And we're going to do that same work now for the asymptotes. But notice the asymptotes aren't already in the graph. And that's because they're not actually part of the graph. They're imaginary lines that determine the behavior of the graph. So we have to figure out by ourselves what the asymptotes are. So where do you think the asymptotes go through? Which numbers? Negative 2 and 3, right? So here's 1, here's 1. So for my asymptote information, I have 1 at x equals negative 2. What factor gave me that? How do I do that? What factor gives me x equals negative 2? Plus 2? And then for the other asymptote, x equals 3, the factored form is x minus 3. So what we want to do next is take those things, and we want to write a general form of the equation using those factors. But we're also going to put a in, remember? A is, in past functions, it's either the stretch or the compression. It's a constant value that determines some things, and we're going to have to solve for it. And so not only are we going to make the factored version, I'm going to throw an a in there as a placeholder. And so we want to create factored form with a. So it'll be y equals, and I'm going to give myself a fraction bar because this is a rational function. It's going to look like a fraction. A will go on top, and then I have to figure out where to put my factors. Well, the factors that I got from my roots, am I putting those in the top or the bottom? Top. So where did the factors from the asymptotes go? Bottom, right? It's root information in the top, asymptote information in the bottom. So my root factors are x plus 1 and x minus 4. And then on the bottom go my asymptote factors, x plus 2 and x minus 3. So in order to figure out what A is, I need to plug in a point and solve for it. Right? So what we always try and do is find a pretty point. Your homework will have a pretty point already specified for you. In this problem, we're going to use 2, 3. Okay, so we're going to plug in pretty point and solve for A. Pretty point just meaning it's a nice integer values for the x and the y. Or it doesn't have to be integers, but it has to be an actual point. So the point I've given you is 2, 3. What am I putting 2 in? Where am I putting the 2 and where am I putting the 3 in that? Right. 2 is x, 3 is y. 2 is x, 3 is y. So putting 3 here. A stays A because we're trying to solve for that. X is 2. Everywhere you see an x. And to follow your order of operations, you simplify each of those parentheses. Okay, so you're going to simplify all 4 of those before you go to the next step. So you should have a 3, a negative 2, and on bottom a 4 and a negative 1. And now we multiply those together. So 3 equals negative 6a over negative 4. All day, people have wanted to just simplify the negative 6 over negative 4. You're welcome to. I just want to multiply both sides by negative 4. Eventually, you have to do that anyway, so I'm just going to do it right now. You're welcome to simplify the negative 6 over 4, but to my mind, it just creates an extra step, which is no big thing, but if you feel compelled to do that, you certainly can, is what I'm trying to say. So negative 12 equals negative 6 over a. Divide both sides by negative 6. A equals 2, which is great. Really feels like we're done. Not done, right? Because the A wasn't my final answer. The equation of the graph is my final answer. So the very last thing you have to do is take that A and plug it back into that general factored form. Okay? Plug A into general form that we found a few steps ago. So my final answer will be y equals A, which is 2, times x plus 1, x minus 4, x plus 2, x minus 3. I'm not going to ask you to do that. You said you could. So Brianna asked, you know, do I want you to FOIL these things back out? No, I don't want you. That's just going to create one more way you could get the answer wrong on that, you know, by making a mistake. So I'm fine with the factored form.